So we want to show that the vectors u and v in this figure are equivalent. So vector u is, and I like to put an arrow to make sure because I cannot make it bold, so please do the same thing. So vector u is the same as vector pq, okay, and we know that p is the point 0, 0, and I know that the point q is the point 3, 1. So let me find the magnitude, and similarly let me write this also, and vector v is the vector rs, where r has coordinates 2, 2, and s has coordinates 5, 3. So basically, first to show that the two vectors are equivalent, I need to find two things. First, I need to find that they have the same magnitudes and the same slopes. So let me find the magnitudes first. So the magnitude of vector u, is basically the distance from P to Q. So it is the distance, and hopefully you remember the distance formula. It's going to be 3 minus 0, so final minus initial, plus 1 minus 0. So basically you find square root of 10. Similarly, I need to make sure that I use two lines for the magnitude, sorry. So the magnitude, some people use 2, some people use 1, so I might change. So the magnitude of vector v, is going to be the distance of rs, so it's going to be 5 minus 2 squared plus 3 minus 2 squared, and again it's square root of 10. So they have exactly the same magnitudes. So let me talk about the slopes now. The slope for the first one, so I'm going to call it the slope of u, is going to be y2 minus y1, so 1 minus 0 over 3 minus 0, which is exactly 1/3, and the slope of v is going to be 3 minus 2 over 5 minus 2, which is also 1/3. So basically you can say that u and v are equivalent. So here we're looking to find the component form and the magnitude of vector v that has initial point negative 2, 3 and terminal point negative 7, 9. So again, we always see the idea as terminal minus initial, final minus initial. So vector v in component form is going to be, the final is negative 7 minus 2, comma 9 minus 3. So that means that this is equal to 7 plus negative 7 plus 2, which is negative 5, comma 6. So vector v in a component form is negative 5, comma 6. Now the magnitude of v is going to be the square root of negative 5 to the power of 2 plus 6 to the power of 2, which is square root of 25 plus 36. So is root 61. So the magnitude of v is the square root of 61. So this is the component form and this is the magnitude. So now for A, we have to add the two vectors. So vector u plus vector v is going to be 1 4 plus 3 comma 2 equals 1 plus 3 comma 4 plus 2, very easy, and you get 4 comma 6. Now for b, you get u minus v, so it's 1 4 minus 3 comma 2, so it's 1 minus 3 comma 4 minus 2, and you get the final answer of negative 2 comma 2. And then for c, you get 2u minus 3v. Notice how I put the arrow, that's important. So 2 times 1 comma 4 minus 3 times 3 comma 2 is going to give you vector 2 comma 8 minus vector 9 comma 6, and that becomes 2 take away 9 comma 8 take away 6, and you get the final answer of negative 7 comma 2, and that's the final answer. So for the first one you get 4 comma 6, negative 2 comma 2, and negative 7. So this is a very important problem. We need to find the unit vector u in the direction of v negative 6 negative 1. So the first thing we need to do is we need to find the magnitude of v. That's very crucial. So this is not very difficult to do. So 6 squared, that's negative 1 squared, so this is square root of 37. So this is the magnitude. So vector u, which is a unit vector, is going to be the unit vector in the direction of v, so it's going to be v, vector v, over the magnitude of v. So basically that's 6 over root 37 comma negative 1 over root 37, and you can leave it in this form. Now we need to verify that the magnitude is 1. So let's see what is the magnitude of vector u. It's going to be 6 over root 37 squared plus negative 1 over root 37 squared square root. So the first one becomes 6 squared is 36 over 37 plus 1 over 37, and this is square root. So this is 37 over 37 square root, which is 1, and that's the answer. So for this problem we need to find the unit vector of PQ. So let's first find actually PQ, the vector PQ. The vector PQ is going to be nothing else other than negative 7 minus 1 comma 8 minus 5, which is negative 8 comma 3. Now we need to find the magnitude of this vector. The magnitude of this vector is going to be negative 8 squared plus 3 squared square root, which is going to be 64 plus 9 square root, so it's square root of 73. And finally the unit vector, it's going to be this negative 8 over root 73 comma 3 over root 73. I'm not rationalizing, usually we don't rationalize this, and let me verify that this has magnitude 1, it's going to be negative 8 root 73 squared plus 3 root 73 squared square root, so that's going to give me 64 over 73 plus 9 over 73 square root, which is 73 over 73 square root, which is square root of 1, which is 1, and that. So to write PQ as a linear combination vector, when P is 2, 9 and Q is 6, negative 12, sorry. So let's write first PQ. In the component form is going to be 6 minus 2, negative 12 minus 9, so you get 4, negative 21, and then which becomes, so PQ very easily it's going to be 4I minus 21J, and that's it. So let's do the same thing again here. So here vector U component form is going to be negative 8, negative 2, be careful of the double negatives, and then 3 minus 6, and that becomes negative 8 plus 2 is negative 6, negative 3, so that means that U is negative 6I minus 3J, and that's the answer to this.